We're going to talk today about a chemistry concept called the mole. Now the mole is a kind of a weird thing to understand. There is a video that talks all about it and explains the concept in a lovely way. It's on a site called ed.ted. This is the video. How big is a mole? I'm going to put a link to this video on your website. You do not have to watch it. It's only about 4 minutes long though, 4.5. And I think it's a really good way to understand this, get a big overview of this concept of the mole. So I just recommend it. Now, as to what a mole is it's a word that means a number. We have analogous words in the English language. Dozen, for example. That's a word that means a number. Every time you hear a dozen, you know you're talking about 12 things. Every time you hear the word pair, you know you're talking about 2 things. Every time you hear the word gross, you know you're talking about 144 things. Well, mole is exactly the same. If you're talking about a mole of something, you're talking about 6.02 times 10 to the 23rd of that something. So in that sense, a mole is a word that means a number. And that number is 6.02 times 10 to the 23rd. So, if I said to you, you have 7.13 times 10 to the 24th atoms of sodium, how many moles of sodium do you have? Remember dimensional analysis? This is dimensional analysis. In fact, it's even a one-step dimensional analysis. 7.13 times 10 to the 24th atoms. That's atoms, this is atoms. Well, I know that there's 6.02 times 10 to the 23rd atoms in 1 mole. Oh look, I'm trying to find moles, so I'm done. I can stop there. I get out my calculator. 7.13 second comma 24 divided by 6.02 second comma 23 equals 11.8 moles. A simple one-step dimensional analysis problem. Of course, I can do this the other way. I can say if I have 3.16 moles of magnesium, how many atoms of magnesium do I have? Now I just do it the other way. 3.16 moles of magnesium. For every 1 mole, there is 6.02 times 10 to the 23rd atoms. Plug and chug, and I get 1.90 times 10 to the 24th atoms. Notice how these numbers are really big. If I'm asking you for atoms, I'm going to get a really big number. If I'm asking for moles, I'm going to get a really small number. Not any times 10 to those, for the most part. If you do this math yourself and you get an answer that's times 10 to the 46th or 47th, you're not putting it in your calculator right. Remember, this guy has to be 6.02 second comma 23. No timeses. No 10 with a caret. 6.02 E23, and then you will always get the right answer. Now, of course, I can make this more complicated. Instead of atoms, I could have molecules. All these things that we just finished naming. Methane, CH4. Now, this is not an atom. This is a molecule. But the math is exactly the same. If I said to you I have 3.11 moles of CH4, how many molecules do I have? It's still the same. For every 1 mole, there's 6.02 times 10 to the 23rd molecules. And it's all the same, because 6.02 times 10 to the 23rd is how many things in a mole of that thing. Doesn't matter whether I'm talking about atoms or molecules. I could actually go further. I could say something like, if I have CH4, and I say something like I have 3.11 moles of CH4, how many atoms of H? Now I have to add another step. Now I can say 3.11 moles of CH4. And we go to molecules now. For every 1 mole of CH4, I know that there's 6.02 times 10 to the 23rd molecules of CH4. Now, take a look at this molecule. This subscript, and the one that's assumed here but not written here, tell me how many of these atoms are in the molecule. For every 1 molecule of CH4, I have 1 atom of C and 4 atoms of H. So, I can say for every 1 molecule of CH4, there are 4 atoms of H. That's how I'm going from moles of methane to atoms of hydrogen. So again, now I just multiply this times this times this. 3.11 times 6.02 times 10 to the 23rd times 4 gives me 7.49 times 10 to the 24th atoms of hydrogen. Okay? I can make this even more complicated. Now, let's go back to our idea of the dozen. If you have a dozen cars and you have a dozen pens, you have 12 cars, you have 12 pens. It doesn't matter what you have a dozen of, you always have 12. But the mass of those 2 dozens would be different. A dozen cars would certainly weigh more than a dozen pens. So now, the other definition of mole that we're going to talk about is the mass part. Remember, the number is staying the same, but the mass of the thing is different. Now, think about a periodic table. Here is a periodic table. If you don't know this site, by the way, it's ptable.com. It's a lovely site for if you need a periodic table. Now, remember, every one of these elements on the periodic table has 2 different numbers. It has the atomic number and it has the mass number. This guy, in AMUs, atomic mass units, is the mass of the average atomic mass of all the isotopes of the element based on percent abundance, right? Just what we did in the last chapter. But it's also the number of grams in a mole. That's why the mole is such a weird number. It's set up so this atomic mass unit is also the number of grams in 1 mole. So if I said to you, I have, let's go back to 3.11 again, I have 3.11 moles of sodium. How many grams of sodium? You need the molar mass. So you'd say 3.11 moles of sodium. Now, the 6.02 times 10 to the 23rd number, which is called Avogadro's number, is not in this problem at all. If I don't ask you about particles, if I don't ask you about atoms or molecules, how many of something, then you don't need Avogadro's number. You do not need 6.02 times 10 to the 23rd. What you need when you're talking about grams is you need a mass off the periodic table. So you go here to the periodic table. You say, oh, sodium. Sodium has a molar mass of 22.9876. We're going to round these. We're going to call it 22.99. We're going to round everything to the 100th. So 22.99. So I go over here to the periodic table and I say I go here to my sparkboard and I say for every 1 mole of sodium, there's 22.99 grams. Now, I can say 3.11 times 22.99, and that gives me 71.5 grams. Notice 3 sig figs, 3 sig figs. Of course, I could go backwards. If I said to you, I have 2.91 grams of sodium, how many moles do I have? Then you would say there's 22.99 grams for every 1 mole, and you would divide 2.91 divided by 22.99, and you would get 0.127 moles. Notice this is just dimensional analysis. The units are canceling and the top and the bottom are equal. Now, of course, I could talk about, instead of atoms, I could talk about molecules. So if I had the molecule ethane, C2H6, and I wanted how many grams of that are in a mole of that. Well, C2H6 is not on the periodic table, but carbon and hydrogen is. So what we're figuring out here is something called the molar mass. It could also be called the molecular weight. Okay. So the molar mass of C2H6 is the molar mass of 2 carbons. Carbon, if you look on the periodic table, is 12.01. And hydrogen, I look on the periodic table, hydrogen is 1.01. You'll pretty much know these by heart pretty soon. So 2 times 12.01 is 24.02. 6 times 1.01 is 6.06. That's 30.08 is how many grams are in a mole for ethane. And then if I wanted to do my conversions, I could do the same thing. I could say I have 3.57 grams of ethane. There are 30.08 grams in 1 mole. 3.57 divided by 30.08 gives me 0.119 moles. Now my molar mass could get more complicated if I had a more complicated formula. Let's say I had something like aluminum sulfate, Al2SO43. Now you'll see why all these parentheses are very important to remember. If I'm trying to find the molar mass of this guy, I need 2 aluminums. This 3 distributes because I'm saying I have 3 sulfate groups. So I have 3 sulfurs, and I have 3 times 4, 12 oxygens. So aluminum is 26.98 grams per mole. Sulfur, 32.07. Oxygen is 16.00. Now we multiply. Times 2, times 3, times 12 and add those all up. And that gives me 342.17 grams per mole. So that's called the molar mass of aluminum sulfate. That's how many grams are in 1 mole. So if I'm given grams and I'm trying to convert to moles, or I'm given moles and I want to convert to grams, I use that number. Remember, the mass of any element or compound in a mole, the molar mass of any element or compound, is going to be different. There always are the same number of particles, but the masses are different. Now let's put all these pieces together. Let's say I said to you, I have 4.18 grams of aluminum sulfate. How many molecules of aluminum sulfate do I have? Now this is a two-step problem because I have to go from grams to moles and then I can go to molecules. So I have 4.18 grams of aluminum sulfate. Molar mass, I figured out over here, it's 342.17. So that's 342.17 grams of aluminum sulfate for every 1 mole of aluminum sulfate. Don't be stingy on your labels here, you'll get confused otherwise. For every 1 mole of aluminum sulfate, I know I have 6.02 times 10 to the 23rd molecules. So that's 4.18 divided by 342.17 times 6.02 times 10 to the 23rd is 7.35 times 10 to the 21st molecules. And of course I could do this in any order I wanted. I could start with molecules and go to grams, but I have to go through moles first. Molecules to moles, moles to grams. I can't go straight from molecules to grams. I have to go through moles.